Which of the 5 coordinate versus time graphs, so position versus time graphs, represents the motion of an object whose speed is increasing? We have coordinate versus time graphs, so position versus time again, and we want to find speed increasing. Well, again, when we're looking at these graphs, we know that the velocity is the change of position over change of time. dx dt, if you know the calculus. Just says that the slope of this line, the slope of a position versus time, the change of y over the change of our rise over the change of our run, rise over run, has to be increasing. So that means our velocity has to increase, or our slope has to be an increasingly large number. When we look at the equation y equals mx plus b, it means that this m has to be increasing. So if we draw a tangent line here, look at that point right there, and it's a slightly upward slope. This slope gets ever increasingly large. So we go back and check to see, well, our slope is our velocity. This value is very close to 0. This looks like a value of 1 to me. This looks higher than 1. So this looks like a speed that's increasing. The slope is increasing. The slope of the position versus time graph, or the derivative of the position versus time graph, is velocity. So these slopes getting larger gives us an increasing speed. These other cases, this case right here, if we were to look at the slopes of these values, these slopes right in here are all the same value. They all have the same slope if we were to draw the lines that would cover it. So this would be a speed, but it would be a constant speed. It would be a negative constant speed. This one down here, the slope is actually getting shallower, so this would be decreasing, not increasing, but decreasing speed. Same thing for this one. The slope of the lines get increasingly shallower and shallower and shallower, which means the speed is decreasing, not increasing. And last but not least, if we were to take the slope at different points here, we'll see that it's a constant value here. So all of these cases, by just looking at the slopes of the lines, of the tangent lines, we can figure out that the speed is the one that has the slope that gets a larger value.